All right, we're back to these sample problems. So number 3, in a fertility clinic where in vitro is one phrase. Basically two phrases, in vivo, VIVO, and in vitro, VITRO. Both are Latin. Ideally, they should be underlined or italicized. In vivo, vivacious, vive is the word for alive. So in vivo means in life. So that would be natural in the womb fertilization. In vitro would be fertilization in a glass petri dish or so-called test tube fertilization. But they're not fertilized in the test tube, they're fertilized in the petri dish. By the way, just for curiosity, the first in vitro human fertilization happened somewhere around the time I was in college or just getting out of college. Now it's commonplace. Then it was a huge deal. And it was like, oh no, it's not normal. It's going to be a disaster. And it worked just fine. Anyway, so we have a fertility clinic. And to help couples get pregnant, they are fertilizing eggs in a petri dish and then putting those fertilized eggs into, or not all of them at once, into a woman's uterus, womb, and hopefully it develops and grows normally. Another for whatever it's worth story, there is a graduate of GCS who adopted an embryo. So this woman and her husband were not getting pregnant, and turned out it was something to do with her reproductive system. Her womb seemed like it should work fine, but she wasn't making eggs or something, ova, I don't know. So anyway, some other person had gone through this process that they're talking about in this problem right here, had made several eggs, fertilized eggs, had got pregnant, had had as many children as she wanted, and the rest of the eggs were frozen, left in basically, what do you want to call it? Suspended animation. So she adopted one of these frozen eggs, had it implanted in her womb. It implanted, developed, grew into a baby. She gave birth to her own adopted baby, or the baby that she had adopted. All right, but anyway, just side stories, I guess. It is said that the clinician says that they can increase the chances that the baby is a boy or a girl. And they give you this data. 897 boys, 810 girls. And that's a what, a 87 difference, a difference of 87, which does make it sound like they can maybe shift the odds. Of course, you would have to assume that they were trying for boys on all of these and not trying for boys on some and girls on others. So use the chi-square test to see if the gender of the babies born from the clinic efforts fall within the naturally expected ratio of boys to girls. All right, so there is our observed results. And we need expected. So what is the expected ratio of boys to girls? It's 50-50. Now, technically it's not 50-50. Just a second. Technically it's not 50-50. Taken as a whole, generally there is apparently a slightly larger number of girls born than boys in the world. Apparently the female reproductive tract is a little more hostile to the sperm that carry the Y chromosome and would become male. No one knows why that is, but it's such a small difference. And another interesting fact or study, somebody did a study and, okay, now you have to listen close to get this right. Somebody did a study and in women who lived in a household with no men. Okay, you got that? Women who lived in a household with no males. Women who live in a household with no males are more likely, by ever so slightly small bit, to give birth to a boy baby than a girl baby. Now, by the way, you're saying, wait a minute, live in a household with no males, how did she get pregnant? Well, it's not to say she was never with a male. It's just to say that there was not a male frequenting on a regular basis her house. All right, so anyway, we're going to go with an expected ratio of 50-50 because for all intent and purpose, it is 50-50. The difference is so little. So our expected ratio, if we add those two numbers, we get 1,707 divided by 2 for 50-50, 853.5. Now, you can't have 0.5 babies. Well, you can, but it's not going to live. But for the sake of our calculation, we're going to use the 0.5. So observed minus expected, 897 minus 853.5 squared over 853.5 and the square root of that plus 810 minus 853.5 squared over 853.5 and the square root of that. And if Josh or whoever can type that into a calculator, that would be great.
$2.29.
So chi-square equals 2.29. Now, what is our degrees of freedom? We have, yep, we have two choices, boys or girls. So degrees of freedom is the number of choices minus 1. 2 minus 1 is 1. Oops. All right. Okay, I see you carrying on, Hannah, but can't figure out why. So if we go up to our table, degrees of freedom, we had 2.29. We want a 0.5, 1 degree of freedom. So our number is well below. In fact, it's approaching, it's actually 2.29. It's actually lower than 0.1. So this is well within the range of what can be accounted for by probability. So our null hypothesis would not be that the clinic can shift or change the odds of the gender. Our null hypothesis would be that the fertilities clinic data can be accounted for by randomness. That is well within what can be accounted for by randomness. So we would have to accept the null hypothesis, which means that they are not shifting the outcome. Now, the whole null hypothesis business is just backwards to people. It's backwards to me. I have to stop and think every time. Null hypothesis is there is no difference. But what they were claiming was that there is a difference. Any questions on that one? All right, this next one is going to be a lot more complicated, kind of like yesterday's second one. In the garden pea, yellow seed color is dominant to green. So what letter would we be using? Yellow seed color is dominant to green.
Y.
Okay, why are we going to use Y?
Because it's the dominant one.
Okay, yellow is dominant and it starts with Y. So yellow will be big Y, green will be little y. Word of caution on Y's. You get in a hurry and the big Y's start to look like little y's and vice versa. Okay, inflated pod shape is dominant to restricted form. Now, if you've paid attention to garden peas, or if you've even seen them, they come in a pod, hence the saying like peas in a pod.
Ow.
And some of the pods have bulges around every seed, and you can literally see the seeds in the pod. I mean, where the seeds are, you can't see the seeds. And the others look like a balloon that somebody blew up. And you can actually take these and shake them and hear the seeds rattle back and forth in the pod. So this is inflated. Not to make too big a deal of it, har har. This is inflated and this is constricted. So what is our symbol? What letter are we using to stand for this, to represent this trait?
I.
Okay, inflated is dominant, so inflated will be capital I, and constricted will be lowercase I. All right, considering both these traits jointly, in other words, we're going to put them together, in self-fertilizing dihybrids, got to quit jumping around here. So considering both of these traits jointly, that means we're going to do them together in dihybrids. We're supposed to tell if this follows, oh my goodness, would you stop jumping around on me? We're supposed to tell if these assort independently. In other words, is it following randomness? So, self-fertilizing dihybrids. Dihybrid would be hybrid would be big Y, little y, or big I, little I. Dihybrid would be big I, big Y, little y, big I, little I. So we're doing this cross. So we're going to have to do a Punnett square to figure out our expected. We have observed. Okay, you remember that a dihybrid cross is 4 by 4. A monohybrid cross is 2 by 2. I doubt like crazy that they would have you do a trihybrid cross. Now, I would like, I don't know, let's say Hannah. Tell me what I should write across the top.
Big I, or we can do yellow first, I guess.
Yeah, let's keep them in the order that they're up there.
Okay, big Y. Should we do 2 big Ys?
Nope,
Or
because we're only doing one parent at a time.
Okay. Big Y, little y.
Nope, because you only get one gene from each parent.
Whoa, whoa, whoa.
Okay, first of all, we're only figuring one parent at a time, and you get one of each gene from each parent.
So big I.
Okay,
Big Y, little I.
now you're rolling.
Little y, big I. And then little y, little I. Wow, that's hard to say.
Yep. All right, now Grace, tell me what goes down the left side.
Oh gosh, all right. Big Y, little y.
Nope, you can only get one from each parent.
Okay. Big Y. I don't know.
Okay, you can get this Y and this I. Or you can get this Y and this I. Or you can get the little y and the big I. Or the little y and the little I. Now, the hint here is that if you have two the same, whoops, erase the wrong thing. If you can figure out one, the other one is the same. All right, so across and down. Mies, tell me what goes, do the first row, first box, first row.
JK, wasn't unmuted yet. Big Y, big Y. Big I, big I. Big Y, big Y. Big I, little y. Or
Little-
I.
Yeah,
Wow, sorry. That's
it does get tricky.
yeah. Big Y, little y. Big I, big I. Big Y, little y. Big I, little I.
Josh, give me the second row.
Big Y, big Y, big I, little I. Big Y, 2 little I's.
Two little eyes, yeah, okay.
Big Y, little I, big I, little I. And then big Y, little I, and then 2 little I's.
Oh, Hannah, we're back to you, I guess. Next row.
Big Y, little I, or Y, sorry. Big I, big I. Big Y, little I. Oh, Y. What am I saying? Big I, and then little I. Little Y, little Y. Big I, big I. Little Y, little Y. Big I, little I. Whew.
Rose, I think it's your turn.
Okay. Big Y, little y. Big I, little I. And then big Y, little I, Y, and then two little I's. And then little Y, big I, little I. And then little Y, little Y, little I, little I.
All right, so here are our choices. 103 green inflated. So that would be green is recessive, inflated is dominant. So that would be one big I, at least one big I, and I'm saying this wrong. Green is recessive, so that would be two little y's, except I did those in the backwards order. Yellow constricted, yellow is dominant, constricted is recessive, so that would be at least one big I, Y, yeesh, and two little i's. Yellow inflated would be dominant, dominant, at least one big Y and at least one big I. And green constricted, recessive, recessive, that would be little y, little y, little I, little I. All right, so now we have to do our count. I'm going to do it right here, and then when I'm done, I'm going to erase it. So a big I, big Y's and big I's would be this one right here, one. A big, at least one big of each, one. Big Y, big I, one. Big I, big Y, big I, one. Big I, big Y, and big I, big guy, I don't know. Okay, big and two little I's. Big Y, two little Y's would be here. Big Y, big I. Big I, two little I's. Big Y and a big I. Big I, big Y and a big I. Two little Y's and a big I. Two little Y's and a big I. Big Y, big I. Big Y, two little I's. Two little Y's, big I. And little. Okay, so it's 9 to 3 to 3 to 1. So now we've got a horse round with our math. So let's see. This is 3/16. 3/16 of the total. And this is also 3/16 of the total. And if you don't see what I'm doing or you don't understand why it works, please ask. This is 9/16. And the last one is 1/16.